Let's do this. May 20th, 2024? Getting to be daylight now, around 6 a.m. or so. Excuse me. So, I'm in some real nitty gritty here. I'm trying to take my design 1.0, although it probably should be called 0.00000 umpteen to the power of pi. Uh, so, So we're talking about thinking about the smart agents as microprocessors. Now, how does a microprocessor work? Basically, you have like two registers, and you take data out of memory, whether that's like on a hard drive or in RAM, and load it. You load a word, which varies. Um, I think they're at least up to 64 bits for a word. And I'm sure they're working on 128, but I haven't seen it around. So you load a register with some data, you load the other register with some data, and then you send an opcode like add, right? So the microprocessor says, add, you must want me to take this register and add them together. And then I guess there's another register or an output or something. So, it's 2, 3, 5. And this is the guy that's doing the processing, which is umpteen. God, I wonder if they're up to 100 trillion transistors. See, it's the transistor that makes it all work. I'm sure they have billions of transistors on the current silicon, the chips. So yeah, I don't know, 100 trillion, sure. Again, if we're gonna move into the 21st century, we need to get comfortable with trillions. We're already getting comfortable with billions. A million isn't even a spit in the bucket anymore. I don't know. So yeah. Why I'm laughing is, oh, it's a real pain. Nobody wants to program even an assembly language. It's a pain in the butt because, computers can only do what we tell them to do. Flat, final. And a human's going to be involved because I've had the epiphany that no computing system can exist without a human having configured it. Going back to AI. Okay, artificial. Never mind. Let's get rid of that. But intelligence. There's no intelligence in the system. No, there is no intelligence. We're quite far away from that. Though we'll have to achieve that to get to a machine mind. So we're at the knowledge layer. If we conquer the knowledge layer, I think thinking comes next, and then intelligence, and then cognition, and then mind, and then sentience, and then cyborg, android. I don't know. I'm not going to be around to see it. Stuff is so huge. Yeah, yeah. You want to talk billionaires and stuff? We're talking trillions here. These ideas could very easily, and they probably will. Will I be involved? Probably not. Um, but it'll happen. I've seen it happen time and time again. So, So I don't know. That might not be the right solution. There's going to have to be just buku um, parsing, parsing all through the system. Because, okay, we talked about a microprocessor loading the registers, giving it an opcode, and then you get your results. Um, but we're going to want to send data packets, might be a better way to think of it. But there's going to have to be parsing all over the place because, say, the smart agent gets a data packet. What does it do with it? How does it handle it? Okay, that we're getting back to metadata, a form of metadata. How is it done? Well, how you know how it's done with internet technology? Your data packet has a header, has a block before it even gets to the content. So that's why I think we can call it metadata because that header might not, but it can. It could alter the behavior of the overall system. That's where the knowledge would come from, maybe, because context, ontology. You got context and ontology, which may be the same thing, really. Um, you can get to knowledge. And the next step would be thinking about that knowledge. So a smart agent gets a data packet and it would read the header. Right. And a typical use case would probably be um, to not even bother with the body of the content because maybe its job is to send it along the chain to some other delivery address, right? Yeah, that's going to be a tricky one too. When to use I mean, inherently, every smart agent is a running smart contract, and the smart contract, I think I've run into a back alley, maybe a dead end. So you know what you do as an engineer when you hit a dead end or whatever, you roll back to a known good and proceed forward again. If you think you're an engineer, you probably should learn that technique if you don't already know it. So, talking about the use case where a content section is meant for another. Oh, that's right. I was getting into addresses. It's tempting because every smart contract will have at least one unique address, right? That gives its existence within the overall system. You want to send something to a wallet or whatever, you you put in the address for the wallet, right? Which must be kind of acting like a smart agent. Oh my God. Oh my God. This goddess, 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 goddess. I believe in the goddess. Sure, you can do God or goddess, but I prefer goddess. So there, deal with it. Yeah. What was my epiphany? It was huge once again. God, this stuff is so mind blowing. Um, Lost it. It'll come back. Oh, that's right. Addresses. Um, where I'm going with this is, can we rely on that unique identifier and just use the smart contracts address? That would be very useful. Or do we need to assign our own? I keep thinking of GUIDs, Global Universal Identifiers, which Microsoft made a standard one at one point, but I haven't heard them mentioned in a long time. The idea was that with the algorithm for this big number that's a GUID, you could, I mean, what they say, like every square inch on the planet could have a unique identifier. And a big part of the innovation was, oh, I won't get into all the details that when you're talking about distributed systems, but with the old client server, you got servers out there, and so you got two servers here, and if they're not communicating, or maybe if they are, even if they are, they may end up assigning the same identifier to their database, to their tuples, and then when the two machines, if they do network and try to share data, could run into conflicts. Or that is to say, you know, one of the early TCP/IP things at Tektronix I learned to troubleshoot, an IP address on a network. On a network, I mean, there's ways to subnet and gateways and all kinds of stuff like that, but the IP address has to be unique. So what we're running into is, yeah, I think that was probably it. People would get a new computer, and probably they'd get the same IP address, but then the old computer would go to asset recovery. Well, work groups would go to asset recovery and look around and see what equipment maybe they can pick up for their work group. And so they'd find that computer and bring it in, and then we get a trouble ticket to install it and stuff. And it's like, the reason why we got rid of this in the first place is it has so many problems. It's supposed to be out of here. That's why we recommended that they get a new computer. And yet here's this person, trying to deploy it again. So I don't know. Anyhow, fun and games. I had a lot of fun at Tektronix. I love my work there.